So this video is how you go about calculating speed, time, and distance on the worksheet that I gave you. So as I work through this, I'll show you how I set problems up and how you should be setting them up. So as you're checking your answers, if you didn't do it my way, it's probably a good idea to fix it so that you do it my way. So enjoy. So a football field is about 100 meters long. It takes a person 20 seconds to run its length. How fast, in other words, what speed are we running? So again, the first thing you always have to figure out is what the problem's asking you to solve. So we know that speed is equal to distance divided by time. That's our equation that we're going to use, and then we're going to just simply plug in the information. And so the distance is 100 meters. Time is 20 seconds. Run that through your calculator. 100 divided by 20 is 5. The units you have here are meters per second. And of course, we put a box around it. Okay, on this problem, the pitcher's mound in baseball is 85 meters from the plate. It takes 4 seconds for a pitch to reach the plate. How fast is the plate going? So in this one, we're looking at how fast. So again, that's a speed type calculation. So we know that speed is equal to distance divided by time. So then we just need to solve by putting in our values. So the distance is 85 meters, that should be 85. And it takes 4 seconds for it to arrive. So 85 divided by 4, you run it through your calculator, you get 21 point, and I always take it out to 2 digits beyond the decimal, and then I round it from there. So it'd be 21.25, and our units, because we have to have units with our numbers, is meters over second. And then to show that I'm done, put a box around my answer. So in number 3 in this problem, if you drive at 100 kilometers per hour for 6 hours, how far will you go? Well, in this problem, how far is a reference to distance. So we're going to need a formula that solves for distance. So distance, according to our little equation cards, is velocity or speed times time. So here we have the velocity of 100 kilometers per hour, and we're going to multiply by a time of 6 hours. Notice mathematically the hours cancel away, so that will leave us with 600 kilometers distance, which is a distance measure, and of course I'm going to put a box around it. So in this problem, it states that if you run 12 meters per second for 15 minutes, how far will you go? So what we're really looking for here is distance. How far is a indication of distance? We have distance is equal to speed or velocity times time. So here we have the velocity of 12 meters per second times a time of 15 minutes. Now here's where we have a problem. We have seconds here, so you have seconds down here and you have minutes up here. So what I need to do is I actually need to change my minutes, 15 minutes, into seconds, and I know that there's 60 seconds for every 1 minute. Then my minutes will cancel, these seconds will cancel, and I'll have an answer in a unit of meters, which is a distance value. So when I run all that through my calculator, I get 10,800 meters. And of course, I need to put my famous little box around my answer. So in problem number 5, it states that every summer I drive to Michigan. it's 3,900 kilometers to get there. If I average 100 kilometers per hour, how much time will I spend driving? So in this problem, we're solving for time. So according to our equations, we know that time is equal to distance divided by velocity. So here my distance is 3,900 kilometers. My speed is 100 kilometers per hour. Now in this problem here, what's going to happen is the kilometers will divide away. And mathematically, that hour actually pops up into the top half of the fraction. So when we get an answer, when we run it through our calculator here, we get 39, and of course the unit is going to be an hour. And we need the box. Okay, and that's it. Okay, so in this problem it says that a bullet travels at 850 meters per second. How long will it take the bullet to go in 1 kilometer? So again, where it states how long here, we're actually solving for time. Time is equal to distance divided by velocity. And in our problem, we have a distance of 1 kilometer divided by a velocity of 850 meters per second. And we have a little bit of a problem because we have meters and we have kilometers. And what we're going to need to do is change either the kilometers to meters or the meters to kilometers. I'm going to do it down here where I can change this meter into a kilometer. And I know that for every 1 kilometer there are 1,000 meters. So that meter will cancel with that one. And just down here on the bottom half of my fraction, I've got 850 divided by 1,000. That would give me 0.85 kilometers per second. And up here I have 1 kilometer. So now my kilometers cancel. The second mathematically is going to move up here to the top half of my fraction. So when I get done running my numbers, 1 divided by 0.85 would give me 1.18 seconds as my final answer. In number 7, it says, every winter I fly home to Michigan. It takes 5 hours. What is my average speed? So we're going to solve for speed here. We know that speed is equal to distance divided by time. Now I know that the time that it takes is 5 hours, but it doesn't give us a distance value. So in this one, you have to go back to question 5 that he talks about how he drove to Michigan. The distance doesn't change whether you drive or fly, so the distance to drive was 3,900 kilometers. So that's the distance value we'll use. So when we run it through our calculator, 3,900 divided by 5, we get 780 kilometers per hour. And I would leave it just like that. I wouldn't change the kilometers to meters or hours to seconds. You can do that if you want, but I'm not going to in this problem. In number 8, it says the fastest train in the world moves at 500 kilometers per hour. How far will it go in 3 hours? So far is a measure of distance. And we know that from our equations that distance is equal to velocity times time. And remember, velocity and speed are the same thing. So according to this, we have 500 kilometers per hour times a time of 3 hours. The hour units will cross cancel. 500 times 3 would give me 1,500 kilometers. And of course the box. So in number 9, it says, how long will it take light moving at 300,000 kilometers per second to reach us from the sun. The sun is 15 million kilometers from Earth. So when they're talking about how long, they're talking about solving for time. How long does it take to get from one place to the other? So we know that time is equal to the distance divided by the velocity. We know that the distance is 15 million kilometers divided by a velocity or speed of 300,000 kilometers per second. So the kilometers will cross cancel. Mathematically, that unit of seconds moves up here. And then when we run it through our calculator, we get 50 seconds, which is pretty fast. It's pretty fast in terms of the amount of time it takes light to get there. Number 10, it is 21,000 kilometers around the Earth, and the Earth rotates 24 hours. How fast is it rotating? So again, the key word is fast, which tells me it's a speed equation. So speed is equal to distance divided by time. The distance here is 21,000 kilometers divided by a time of 24 hours. I'm going to leave it as kilometers per hour. So my speed, when I mathematically calculate it, is 875 kilometers per hour. And my final answer.